Algebra 1 students.
Everything is awesome.
That's right. Everything's awesome.
When you're part of a team.
Especially
Everything is awesome.
factoring ax squared plus bx plus c. And if you're annoyed by this song, you're not alone. So I'm going to end this song right now. Alright, so let's talk about factoring ax squared plus bx plus c. The big idea here is by using the AC method, we can take a trinomial in the form ax squared plus bx plus c, and we use the first term and the constant, a and c. The product of those two values is important for us because we can use it to break apart the middle term and then group factoring. Alright, there's a lot going on there. Let's take a look at an example here. The example we have is 2x squared minus 3x minus 20. In this case, AC is 2 times 20, or just simply 40. And what I did over here is I listed possibilities for factors of 40. 1 times 40, 2 times 20, 4 times 10, 5 times 8. Beyond that, they would start to repeat in the opposite order. What I was looking for, because the last term is negative, I'm looking for two factors that have a difference of 3, and that's right here, 5 and 8. So I could rewrite negative 3x as plus 5x minus 8x. So I basically just broke apart the middle term, rewrote it as two separate terms. The beauty in that is then I can factor an x out of the first two terms, a negative 4 out of the third and fourth terms, and look at this, group factoring x minus 4 times 2x plus 5. Alright, let's try that with some new numbers here. So 2r squared minus 7r plus 5. First things first, we've got to figure out what our r value is. Sorry guys, my pen is freaking out here. Alright, I think I'm back in line here. So AC would be 2 times 5, or just simply 10. Now we don't have a lot of options with 10. It's either 1 times 10 or 2 times 5. And what we're looking for is a sum of 7. So I see that right there. So I'm going to rewrite that middle term. Instead of negative 7r, it's going to be 2r squared minus 2r minus 5r plus 5. I haven't changed the value of this polynomial. I've just simply broken apart the minus 7r. Now here's the beauty of this. We can factor out a 2r and we'll have r minus 1. Then I can factor out a negative 5, and I want a negative 5 primarily because I'm trying to make this look exactly the same as this, and that does the trick. If you factored out a 5, you'd have negative r plus 1. You'd be close, but not quite. And so then we have 2r minus 5 times r minus 1. It's a beautiful thing. Onward. Now this time our AC value is a little bit larger, 6 times 40. So 240. We got to find ways to break down 240. Now we could go with big numbers like 1 times 240, 2 times 120, but I'm seeing I need numbers that have a sum of 31. So I might do numbers that are a little closer together, like 10 times 24. Okay, those have a sum of 34. We're close, but not quite. What about this one? 15 times 16 would be 240 if my math skills are good. Sometimes they are. Of course, it might help if I wrote 16 instead of 6. And 15 times 16 is indeed 240, and it has a sum of 31. So I'm going to rewrite this as 6z squared. I'm breaking apart the 31z to be 15z plus 16z, and then we'll have a plus 40 out here. Now again, we're going to look at grouping the first two and the third and the fourth. So I can do 3z times 2z plus 5 plus, and then over here I can take a 4 out. Nope, I can even do better than that. I can take out an 8. That may happen to you as well, where you see one thing and then realize, oops, I could have done better. And here we go. 3z plus 8 times 2z plus 5. And there's the result. Let's take a look at number 3. Here we have 6x squared minus x minus 5. Now again, we're going to use that AC method where we know that AC is equal to 6 times 5, which is 30. And for purposes of the AC method, we can pretty much ignore the whole positive versus negative. Just treat everything as a positive number, and then we'll make adjustments as we move ahead. So here we go, 30, ways to break down 30. There aren't a ton of them. 1 times 30, 2 times 15. Now, one thing I'm noticing is that I'm looking for a difference of just 1. So if I were actually just doing this problem on my own, I would start with numbers closer together, like 5 times 6. So now I know that I'm going to break that middle term up into a 5x and a 6x. Together, they have to be negative 1x. So I'm going to do minus 6x plus 5x. And by the way, the order of these two is not relevant. It'll work either way. Now this one worked out kind of nicely because it allows me to immediately factor out a 6 and an x from the first term, which just leaves me with x minus 1. And over here I can factor out a 5, which leaves me with x minus 1. So 6x plus 5 times x minus 1 is the result. All right, let's look at number 4. This time we have a little bit bigger numbers to work with. AC is going to be 20 times 18, which is 360. Now 360, fairly large number by the standard that we've been practicing here. And it has a lot of numbers that evenly divide. So I actually want to start with numbers that are fairly close together because I can see the difference has to be 9. I don't want to go through the whole list of 1 times 360 and things like that. So one thing I might look at is say 18 times 20. Well, that's equal to 360, but the difference is too small. So maybe I need something different than that. Like maybe 5 goes into that. How many times? 72. Oh, went too far. Okay. How about 10 times 36? I'm still not there. I need to be in between 10 and 18. So I'm looking for numbers that I know go into 360. Well, I know 15 goes evenly into 360, and it's 15 times 24, and there you go. That has a difference of 9, which is what we're actually looking for. So let's do this then. 20w squared, and I'm going to do minus 24w plus 15w, and once again the order of those two wasn't relevant, minus 18. Let's group factor. I can take a 4 and a w out of the first two terms, so that's 5w minus 6. The last two terms, it's a 3, will come out evenly. And we get 5w minus 6 and 5w minus 6, which is what we want. So 4w plus 3 times 5w minus 6 is the factored form. All right, let's do number 5 together. And again, we're getting fairly large numbers to work with. It makes it a little tougher, but the AC method is actually a good method for this. And 35 times 16, I'm getting 560 for that, 560. So breaking down 560, that sounds fun. Well, and I see here the difference needs to be 46. So I'm going to look like I know 5 goes evenly into this. That's 5 times 112, and that difference is over 100. That's too much. Maybe go bigger than that, maybe like 10. That would be 10 times 56, and what do you know? We've found it. 10 and 56. Now, it may take you more than 2 tries to figure out which combination to use, but it will work, and it's just a matter of being patient with it and trying different values. So I need a negative 46 for a middle term, so I'm going to go plus 10a minus 56a, and then finally minus 16. Again, factor the first two terms. 5 and a will both come out of that, 7a plus 2. And the last two, we can factor out a negative 8, and that would give us 7a plus 2. We like that because it's the same. So 5a minus 8 times 7a plus 2. All right, folks, pause the video. Why don't you guys do number 6 on your own, see how you're doing, and when you're finished, hit play, and you can compare your work to mine. All right, folks, you can see my work now. 3p plus 7 times 2p minus 3 is what I ended up with. 126 is a little bit trickier number to break down than some of them we're used to, but it works, and you can use a calculator. But I just started testing. I tried 6, and well, 6 times 21 is a good factor, but it doesn't have a difference of 5, which is what I needed. So then I just kept kind of working closer to the middle, numbers that are close to each other, and eventually I found 9 and 14. Notice this time the middle term was positive, so I needed the larger of those two terms to be positive, and then it all worked out real nicely after that. All right, folks, I know this is a little bit of a challenging topic, but you're up for it. Come to class to work hard, and we'll see you soon.